Hello, grade 12s. I am Miss Ndabeni, and I'd like to take this opportunity to welcome you into our Eastern Cape Department of Education broadcast studios. Today, I'm going to be taking you through a lesson in organic chemistry, and I'm going to start you off with a first subtopic, which is that of nomenclature. So, in this topic of organic chemistry, we've got a lot of terminologies, terms, and concepts, which I'm going to take you through first, so that by the time we get to the gist of things, we are all comfortable and we know what it is that is expected of us. So we are going to be working with organic molecules. We're going to be working with giving our organic molecules names, which are called IUPAC names. And so I am going to introduce you to terms and concepts which are needed, as well as skills that are needed for this. Now, what is organic compounds, or what are organic molecules? Organic molecules are molecules that are mainly made up of the carbon atoms. Now, I'm going to show you here just what it is that we mean when we say it's molecules that are mainly made up of the carbon atoms. I've got a slide here which has got the list of these organic molecules. Now, I'd like to bring to your attention here, though you might not understand as yet, but look at these structures here. The main constituents, or the main atom that we see present in all these compounds, is the atom carbon. Hence, we say that organic molecules are molecules that are mainly made up of the atom, which is what? Carbon. Now, these molecules are classified into a few families according to their structural properties. However, we don't refer to them as families, or we don't say we classify them into families. We use the term homologous series. So all our organic compounds are classified into different homologous series. In totality, we're going to be doing 9 of these homologous series. So the term homologous series is a new term to you, and so I'm going to break it down to you and explain what a homologous series is. Now, a homologous series are a group of compounds with the same functional group and the same general formula. This is one of the terms that you need to know for your examination, where they can ask you to define what a homologous series is. They can ask you to define what an organic molecule is. So we say once again, homologous series is a group of compounds with the same general formula as well as the same functional group. Now, what does that mean? I refer you back to these structures here which I've got. Now, in totality, we've got 9 of these homologous series. We've got the alkanes, the alkenes, the alkynes, the haloalkanes, the alcohols, the aldehydes, the ketones, the carboxylic acids, as well as esters. All of those, the 9 of those, are what we call homologous series. Now, we said a homologous series is a group of compounds with the same functional group as well as same general formula. What is a functional group? Now, if you look at these two structures here, or if you look at these structures which have been drawn across here for functional group, you will see here that for alkanes, there are single bonds between my carbon atoms. And if your structure has got single bonds only between carbon atoms, it is going to be classified as an alkane. In addition to that, all structures which are called alkanes have got a general formula of CnH2n plus 2. Now, what is N in that formula? N is a number of carbons. What this then tells us is that for our structures, be it an alkane or an alkene, or an alkyne or an alcohol, they are going to have different number of carbons and hence different number of hydrogens. That means it is possible for us to have an alkane with 1 carbon, because therefore N is going to be equal to 1, and we're going to have the hydrogens which are going to be 4. Where does the 4 come from? From the 2N plus 2. So it's 2 times 1, which is 2 plus 1 to give us what? A 4. Then we've got the second homologous series, which is alkenes. Now, all our alkenes, how are we going to classify, how are we going to identify if a molecule is an alkene? If between 2 carbon atoms is a double bond, as we see here, if between 2 carbon atoms is a double bond, then that molecule is going to be classified as an alkene. And as per the definition, that says homologous series are a group of compounds with the same functional group and same general formula, all our alkenes are going to have its general formula of CnH2n. Then we have alkynes. Alkynes have got a triple bond between the carbon atoms. One other thing I want to bring to your attention is the issue of that a carbon atom has got a valency of 4 electrons, and so we need to ensure that each time we draw bonds around a carbon, we complete what is called the octet rule, which we learned in grade 10 when we were drawing covalent structures, when we were doing chemical bonding. Now I'm going to refer to you to how we are going to identify the homologous series, as well as in context of its definition that says a homologous series is a group of compounds that have got the same general formula as well as the same functional group. Now, I made mention of the fact that in totality we've got 9 of these homologous series that we are going to do. So I'm just going to take you through the 9 of these homologous series as introduced. I introduced to you from alkanes right up until the esters. Now, how do you know, or how do you identify for your compound to be an alkane? Now, all our alkanes, according to the functional group, have got single bonds between the carbon atoms. I'm just going to quickly here circle these single bonds that I'm talking about so we understand what it is when we're talking about our functional group. This is the single bond I'm referring to. Between those two carbon atoms are single bonds only, and so that makes that structure an alkane. In addition to that, we said that they've got the same functional group and also they have the same general formula. So this is our general formula for our alkanes. Alkanes have the general formula CnH2n plus 2. What then it means is that for these alkanes, they will range in structure in the number of carbons. Some will have a structure that has got 1 carbon and a structure that has got 2 carbons, 3 carbons. Now, for our purposes of physical sciences, grade 12, we'll only be naming structures that have a maximum of 8 carbons in what we call the parent chain. So if our structure, for example, just to put the idea of a general formula into context, if our structure has got 1 carbon, how many hydrogens do I expect that structure to have? I expect it to have a total of 4 hydrogens. Where does the 4 come from? It's the 2 times 1, which is a 2, plus 2 to give me a total of 4 carbons. Moving along to the next homologous series, which is alkenes. Now, alkenes, how do you identify your compound? If it's an alkene, there will be a double bond between 2 carbon atoms, as we see here in this structure. Now, if in your structure there's a double bond between 2 carbon atoms, then it's an alkene. It belongs to the homologous series called alkenes. Now, also alkenes, all our alkenes have got a general formula, and which is CnH2n. And what does that mean? That means if, for example, your alkene has got 2 carbons, because N stands for the number of carbons here, you expect that alkene to have a total of how many hydrogens? A total of also 4 hydrogens, because N is 2 and 2 times 2 is a 4. Then our next homologous series is alkynes. Alkynes are characterized by a triple bond between the 2 carbon atoms, and they also have a general formula CnH2n minus 2. Again here, N stands for the number of carbons, and so if our alkene, for example, I'm not going to take the number 2 now, let's say that if our alkene has got 3 carbons, so N is equal to 3, how many hydrogens do I expect? I expect to have 2 times 3, which is equal to 6, minus 2, and that's going to give me a what? A 4. So if in my alkyne structure, pardon me, I might have called it an alkene. If in my alkyne structure where there are triple bonds between the carbon atoms, there are 3 carbons, we expect to have how many hydrogens? 2 times 3, which is a 6, minus 2, which is still going to give us a what? A 4. The next homologous series that I'm going to take you through is haloalkanes. You will remember halogens when you did the periodic table of elements in grade 10, that these are all your group 7 elements. In particular here, we'll be looking at the element fluorine, bromine, iodine, which will be attached to our organic structures. Now, our haloalkane alkanes have got the general formula CnH2n plus 2. They've got the general formula CnH2n plus 1, not plus 2, CnH2n plus 1 X. And what does the X stand for here? Here our X could be the chlorine, it could be the fluorine, it could be the iodine. Those are all group 11, group 7 elements, not group 11, group 7 elements. Following that, we've got the alcohols. Now, how do you know if your organic compound is an alcohol? Here we've got what we call the hydroxyl as our functional group. This entire thing is the hydroxyl. The carbon which has been bonded to the hydroxyl OH ionic compound by a single bond. That is called a hydroxyl group, and it is the functional group of alcohols. Now, alcohols have got the general formula CnH2n plus 1 OH. Now, let's say for this example, N is equal to 2. So therefore, how many hydrogens would you expect to have in this structure? You would have the hydrogens which are 2 times 2, which is going to be a 4, plus 1, which is going to be a what? A 5. But, however, there is that hydrogen which is part of your hydroxyl. So in totality, you are going to have 6 hydrogens here. And so that is why you're going to find some textbooks referring to the general formula of alcohols as CnH2n plus 2O, because they are taking into consideration that hydrogen there that belongs to the hydroxyl. Now, I'm going to come back. I'm just now going to quickly take you through and we'll learn how to name these compounds. But I was just trying to bring to your attention what it is that we call a functional group and what it is that we call a general formula. The next homologous series that we have is aldehydes. Now, aldehydes, how will you see that your compound is an aldehyde? It's going to have this carbon, which has been double bonded to an oxygen, and this carbon is going to be your first carbon in your structure. We are going to do these structures and you'll understand what we mean by saying a first carbon. This is going to be your first carbon in your structure. So your first carbon in your structure is double bonded to an oxygen, and also there will be a hydrogen on that terminal carbon. It has got a general formula of CnH2nO. So which then means, again, if I've got 2 carbons on my structure, I expect to have 2 hydrogens, sorry, not 2 hydrogens, but 4 hydrogens and 1 oxygen. We've got ketones. Now, it's interesting that you will see that ketones and aldehydes have the same general formula. Now, if we're looking at this general formula as well as this general formula, it's exactly the same, CnH2nO for ketones as well as aldehydes. But however, in our ketones, our functional group is not on a terminal carbon. That is, it's not on the first carbon. However, it is on a carbon which is non-terminal. What do we mean when we're talking about a non-terminal carbon? I did say in the introductory stage here that we are going to be getting structures that will have up to a maximum of 8 carbon atoms. So there will be carbons that will be in the middle of the structure, just like this one. There's a carbon on either side, and there is a carbon between them that has been double bonded to an oxygen. So that makes that a ketone. Whereas for this particular compound, the double bond between the carbon and the oxygen is on our first carbon, and on this one, it's on what we call a non-terminal carbon. Now, we are going to come back to this issue here of an aldehyde and a ketone having the same general formula, but not having the same functional group. The fact that that double bond between the carbon and the oxygen is on our first carbon makes this an aldehyde, and there's a name to that functional group, and it's called a formyl. But because here the double bond between the carbon and an oxygen is not on our terminal carbons, the name given to this functional group is called a carbonyl. Then second but not last, we have our carboxylic acids. Carboxylic acids have got the general formula CnH2 H2NO2. And how will you identify your carboxylic acid? Your carboxylic acid is going to have these atoms as our functional group. It is a carbon that has been double bonded to an oxygen as well as bonded by a single bond to our hydroxyl. This we call a carboxyl, the name of the functional group, and it has the general formula CnH2nO2. And lastly, for our homologous series, we've got esters. Again, it's going to be interesting to see that the esters and the carboxylic acid share the same general formula, but they do not have the same functional group. Now, what you're going to find interesting with esters is that there will be an oxygen in between carbons. There will be an oxygen in between carbons in the parent chain, and on either side of the oxygen, you will find that there's a carbon that will be double bonded to an oxygen, and on the other side is a carbon that will either be bonded to two hydrogens or another carbon. We'll break it down as we go along and we'll understand. I understand that the concept for now is new, but you are going to understand as we go along what we mean by these functional groups. So here is our functional group here for our esters. Now, esters again and carboxylic acid share the same general formula, but they don't share the same functional group in as much as they share the same general formula. So there's a term that we are going to give to that, but that we are going to discuss later on in our slides. Now, I'll let that sink in for a moment, and I'm going to go on to the next aspect of how we're going to name our structures. So just to summarize everything that I've crammed in right now, I introduced to you 9 homologous series that we are going to be looking at as our part of our organic chemistry and naming of these organic compounds. It's the alkanes, characterized by single bonds between the carbon atoms. It's the alkenes, characterized by double bonds between the carbon atoms. It's the alkynes, characterized by triple bonds between the carbon atoms. It's the haloalkane. Basically, it's an alkane structure, which means single bonds between the carbon atoms. However, there will be a halogen attached to one of those carbons. There's the alcohol, characterized by the hydroxyl as our functional group. There is an aldehyde, characterized by our formyl as a functional group, a carbon double bonded to an oxygen on our first carbon. There's the ketones, characterized by our carbonyl group, which is a double bond between a carbon and oxygen on a non-terminal carbon. Then we have our carboxylic acids, characterized by what we call the carboxyl group, which is a carbon double bonded to the oxygen as well as a single bond between the same carbon double bonded to the oxygen and the hydroxyl. And lastly, it's the esters. In the esters, we have an oxygen in between carbons, and we have a carbon that will be double bonded to an oxygen, and the structure may continue. We may have more carbons this side. Same applies to this one. So we may have more carbons this side, or we may have hydrogens only. So those are our homologous series grade 12s that we are going to be working with. And so when I come back just now, we are going to look into more of the terms and concepts that you need to know. Some already we've covered, such as the concept of a functional group. Then I will take you through the next terms and concepts. Make sure that you stick and you tune in to get more. Okay, so we are going to continue with our terms that we need to know for this chapter. The next term that I'm going to discuss, or we are going to explain, we've already sort of briefly made mention of it, is that of a functional group. Remember, we looked at the 9 homologous series from alkanes right up until the esters. And we were referring there to bonds, atoms, the hydroxyl. If I can just quickly show you right here. Try and explain how you identify which homologous series you are dealing with. So here I referred to single bonds between carbon atoms. In that, I was referring to how you would identify an alkane, or if a compound is in the homologous series of alkanes. So A functional group is a bond. That means when we say a functional group is a bond, here we are looking at the single bonds between the carbons, the double bonds between the carbons, that makes it an alkene, the triple bond between the carbon atoms, that makes it an alkyne. So the definition of a functional group says it is a bond or an atom. What's an atom? An example of when we say an atom is when we're looking at haloalkanes. Haloalkanes have got the halogens, which could be the fluorine or the chlorine or the bromine, or the group of atoms. A group of an atoms is an example of the hydroxyl right here. It's an example of the carboxyl for carboxylic acids. It's an example of carboxyl for the carboxylic acids here. So one of the definitions that you need to be able to recall, as I've said, is this one here of a functional group. So we say that a functional group is a bond, be it single bond, double bond, triple bonds, or an atom, be it your halogen, or a group of atoms, your hydroxyl, your carboxyl, that will determine the physical and chemical properties of an organic compound. Chemical properties, we're going to be looking later on in one of the videos that we are going to do later on in this chapter, the types of reactions that these organic compounds can undergo. Physical properties refers to what you learned in grade 10 in as far as boiling points, melting point, vapor pressure, and the intermolecular forces of grade 11, which is the next subtopic of this chapter. I'm going to have a video later on where we're going to be discussing physical properties as well as chemical properties of organic compounds. Okay, then another term that you need to know and recall here is that of general formula. We're just trying to expand here grade 12 on these words that these concepts that we introduce when we define a certain concept. We're putting into context here. Remember, we said a homologous series are a group of compounds with the same functional group. So now we are looking in detail as to what a functional group is, as well as the same general formula. Now, in my introduction here, I referred to general formulas of our organic compounds. You remember that I said that for our alkanes, they have got its general formula, which is CnH2n plus 2. For alkenes, they've got a general formula, which is CnH2n. For alkynes, CnH2n minus 2, and so on and so forth. So therefore, what is a general formula? A general formula is a formula which is used to determine the molecular formula of any member in a homologous series. Meaning, if I know, for example, that I have an alkane and my alkane has got 1 carbon, I can use the general formula of alkanes, Cn H2n plus 2, to determine the molecular formula of that alkane. Don't forget to click the like button, and you can follow the Eastern Cape Department of Education and subscribe to their YouTube channel. And until next time, keep it locked.